In this segment, we want to take a look at exponential modeling, which means we're going to look at some real data and we're going to try to fit an exponential function or equation to that data and then use that to make some predictions. Okay, so this example is about the debt of older Americans, which unfortunately has been increasing exponentially in recent years. And we've got our data listed in the table here, so starting from 2000 through 2008, here is the amount of debt in those households. We don't want to use the 2000, 2002, we want to use 0 for our initial year, and then the number of years since that point, so the 2, the 4, the 6, and the 8. That just really gives us nicer numbers in our equation. Right? So what I'm going to do is I get my calculator and I go to the Stat menu, and the first thing we have to do is edit and input our information. Now I have already done that, so I've got my lists already completed. If you need to pause, go ahead and pause and fill in the data. If you've got data in here that you need to clean out, arrow up to the list header and hit clear and then enter, and then you've got a clean column to start with. So I'm going to quickly put that back in. Make sure that you've got your data exactly right. Double check it, triple check it, because one little mistake here is going to throw off your entire problem. Now we want to get out of there and we want to go to our y equals menu. Clean out any equations that are in there just so they don't interfere with our picture, and make sure that you go back up and highlight that plot 1. So just arrow it up and hit enter, turns it off and on. Okay, so you want it highlighted. Now if we go to zoom and go down to number 9, zoom stat, that's going to take my information here and plot it out on a scatter plot for me. So it's kind of going up, and then all of a sudden it really goes up. So that kind of looks like maybe an exponential function might be a good fit for this. How are we going to get that? Well, we quit this and we go back to that stat button, go over to calculate, and I want not linear regression or quadratic or any of these. I scroll down till I get to 0, which says EXP regression, so exponential regression, and I hit enter. Now to tell it to use list 1 for x's, list 2 for y's, and copy the whole thing into my y equals, we're going to do this. We're going to find list 1, which is right here above 1, so second on list 1, comma, and then second and list 2, comma, and then for the variables we go to the vars button, we go over to y variables, we want a function of y1. Right, so it's going to use x as list 1, y as list 2, and then paste it into y1 when I hit enter. So I've got this copied on the screen for us here, and the a is just the coefficient, the b is the thing that's being raised to the power. So on paper I usually write down, I round it off a little bit, but just so I have a reference point, I write down what the equation would look like. Okay? But the calculator has it all in here with all the decimal points, so it has the most exact equation in there. Now we're going to use that to make some predictions here. They want us to estimate the debt in 2014. Well, I'm not going to use 2014 for my x. That is, x is the number of years since 2000, so I'm only going to use 14. Okay, so what I do is I grab my calculator, and I'm not going to punch in all those numbers. I'm going to go to vars, and I'm using a y variable as a function name. So y1 of the 14, and it's going to give me the answer here. Oh my goodness, $111,836 approximately. Kind of scary. Well, now the last question we have is, in what year is the debt expected to exceed $140,000? So the equation we need to solve is 140,000 is our answer, equals to this, and I just wrote down the rounded off version here so I didn't have to copy it all. This, if I were to solve algebraically by dividing through the coefficient and then using the natural log and all of that stuff, this would give me an approximate answer. But since I've already got the information in my calculator, let's use the most accurate answer we can get. So in my calculator we had the y1 already pasted in for us. We're just going to paste in 140,000 for y2. Okay, now I've changed my window because I'm thinking, well, maybe 20 years from 2000 it would be that much. And then for our y's, we want to go from 0 maybe up to 150,000, so at least we surpass this 140,000 a little bit. And then I take a look at my graph. So there's our original data, here's our model going through that data, and then we're going to see a horizontal line for that 140,000. And our job is to figure out where they intersect here. So second, calculate number 5. is intersect. Is this your first curve? Yes. Okay. Is this your second curve, that line? Yes. And then what's your guess? Well, I need to move over this way. Close enough. Hit enter, and it tells me here about 16.5. So that's 16 and a half years from 2000. Could be 2016, 2017. Either answer should be acceptable.